All right, so we just built this little simple Simon game here. I show how to do it in the making of NeoPixel 214. So this is in the making of 214. This is 214 now. Okay, we got a red, or I guess that's red, a blue, a green, and a yellow button, right? And we got a NeoPixel ring. What we're gonna do is make simple Simon. Okay, so there's 16 LEDs. We're gonna have these four be green, these four be yellow, these four be blue, these four be red, and it's gonna light up. And we have to remember that the yellow one lit up. Hit the yellow, and then yay celebration, and then yellow, and then green. Then we hit yellow, green, yay celebration. Right. So here we go. The current blinking right here and back, that's the default program on the Nano. So first thing we're gonna do is wipe that off there because it's annoying, and then test and make sure everything works because I didn't even do that last time. Okay, so here's a basic set of NeoPixels. So we have the library, the pin, the count, create the object called strip, and then strip.begin, strip.show, and then a loop here. Okay, so we're gonna need a lot more than that to get this thing running. But first of all, LED pin is on A0 or 14, so that's all good there. There's 16 pixels on this strip. Okay, and what I'd like to do is go between each pixel to see which one's the first one and which one's the last one to make sure we're going in the right order, right? Because I didn't even check that. Like if I'm off by one, I don't want like the game tilted slightly. I want it like straight on, like to make sense. Okay, so for int a equals 0, a is less than LED count, a plus plus. All right. So what I'm going to do here is strip dot set pixel color. I guess I should spell pixel right. There we go. Turned orange. I want a comma strip dot color HSV. Oh, that's a capital C. My bad. And yeah, what do we want here? We just want a random color. Random 65536. And the color HSV and the random parentheses and the color HSV parentheses and the set pixel color parentheses. Semicolon strip dot show. And we'll do a little bit of a delay here, so it doesn't just instantly show them let's actually observe this as humans. Delay of 50. Okay, so 50 times 16 equals 800. So the whole boot up sequence will be 800 milliseconds, almost a second. Okay, not a big deal. And then I want it to turn off. There we go. And once it's all done with that, then it's going to show that last pixel being off, and then we'll be good. Okay. So that'll also get rid of that annoying flashing back here. I'm going to hit upload, and we'll see what happens. Oh, there's a few things I missed here. Okay. Definitely not going to work right. So tools, we're not using a nano or Uno anymore. We're using a nano. So go to our AVR boards, board, AVR boards, nano. This is a 328p. I don't think it's an old bootloader. If it gives us issue, we'll change that. I think this one's at 65. I don't know. Let's see. So it's plugged in right now. We see 51 and 65. I'm going to unplug it. Okay. And then I'm going to open this back up again. Tools, port. So yeah, definitely 65. Okay. Plug it back in. tools port 65. Okay, yours is going to be a different port, I'm sure. Okay, so we're on 65, and we're still using AVR ISP Mark II. All right. Now let's try uploading it. It's uploading. All right. And there it goes. Okay. So I'm going to hit reset on the board. And it starts right there. Perfect. Okay, so these four are in line. That's going to make programming a lot easier because it's going in the right direction. Okay, so we got to set up a bunch of stuff here before we can even get started. Okay, right now, what I want to do just to test things is if I hit yellow, it's going to turn on the yellow ones. If I hit green, it's going to turn on the green. If I hit blue, it'll turn on the blue. If I hit red, it'll turn on the red area. Okay, so first of all, way up here in our code, I'm going to do a variable called pinput. So int pinputs, they're pin inputs, right? So I call them pinputs. And there's four of them. Equals brace. So let's see, we're on 2, 3, 4, and 5. Those are the pins we used. Okay. And so after it's done doing that little testing for int a equals 0, a is less than 4, a plus plus, and I want to pin mode pinputs a comma output. All right. Cool. So what it's going to do here is when a equals 0, it's going to come to the pinputs array, and the 0th one, which is 2, it's going to turn that into output. Then it's going to equal 1, which is 3 here, make that an output, etc. So we have all the buttons as outputs. Okay, now I'm going to run or make a subroutine. I'm going to call it set Simon. So void set capital S Simon. Okay. We need a couple different things here. We need colors, I guess. uh so I guess if I turn on 0, I'll have everything on the strip turned off. If I set 1, this one will turn on. 2, 3, 4. Actually, I don't like that. I'm just going to have 1 is yellow. I'll have a whole different thing for blanking everything. So int, see, sections or sex. I like to put Z out on all my subroutines so they don't interfere with anything global. Okay. And then, see, we need to have colors too. So int colors. That's an orange one. I'll say CLR. CLRS. Colors. And that's going to be, let's see, 4 long, but 3 wide. Okay, because every color on the NeoPixel is red, green, blue. Right? So do, equals. And then 2 braces. So we have yellow, green, blue, red. So yellow would be, I don't know, 100 red, maybe 155 red, comma 100 green, and 0 blue. I like it to equal 255, so I know it's just taking 20 milliamps of power. Okay, and that curly, comma enter. Start another curly. Okay, so we got, let's see, so yellow, then green. Green's easy, right? RGB. 0, comma 255, comma 0. The brace. Let's do some copying and pasting here. Oh, I want that comma too. There we go. Okay, and the curly semicolon. Okay, so we got yellow, green, blue, and red. So blue's another easy one. Red's another easy one. Well, it's that yellow that I'm going to be nitpicking this whole video, I'm sure. It's hard to get a good yellow out of this stuff. Okay, so these are our colors. Okay, so set Simon. So what I want to do here is there's 4 of them, so there's 16 altogether on the ring here, right? And I want to light 4 of them the right color. So int, not int. What are we doing? 4. Yeah, 4. Int a equals 0. A is less than 4. A plus plus. In the parentheses, start the curly. So strip dot set pixel color. Let's do so the sections, the segs times 4, right? Because 0 times 4 would be this area. 1 times 4 would be this area. 2 times 4 would be here, right? It started at 8. So 0, 0, 1, 2, 3, right? And then 4, 5, 6, 7. Then 8, 9, 10, 11, 12, 13, 14, 15. Okay? All right? So start on that section plus A, right? So if I tell it to do 0, it's 0 plus 1, right? 1, 2, 3, or 0, 1, 2, 3. 0 plus 0 is 0. 1, 2, 3. So it's going to do all 4 of these, or all 4 of these, all 4 of these, all 4 of these. And then the colors will be based off this array here, comma. So we're doing CLRS sex. Is it sex? Oh, segs. Sections. There we go. And then 0, 1, 2, right? Red, green, blue. Whoops. Close that bracket. 0. Okay. Control C, B, B, B. And the parentheses, semicolon. Okay. So the red pulls the first one, green pulls the second one, blue pulls the third one. Okay. So this should set all 4 of these correctly depending on which Simon it is, right? Or which section it is, right? And I think that's about all we need to do. So that's our subroutine called set Simon. Okay? So 4 int a equals 0, a is less than 4, a plus plus. Start a curly brace. So if not digital read, pinputs bracket A. So if any of these are pressed, set Simon. Let's see, yeah, set Simon. I guess A. So that corresponding one should show, and then you do a strip dot show, and then in memory we have to turn everything off. So I'm going to do a void clear pixel. Okay. And then it doesn't need any info. It's just going to clear all the pixels. So 4 int a equals 0. A is less than LED count a plus plus. Strip dot set pixel color. Let's see, a comma 0 comma 0 comma 0. Wait, how did I make that brace? Huh, okay. This made a brace accidentally. Wonder how I did that. Not a brace, a line. Anyways, okay, so what this does is turns all the pixels off in memory, right? So now, when I hit a button, depending on which button I hit, it should light up a series of pixels on the ring and then show it. And then afterwards, in memory, we're going to do clear pixel. Clear pixel, clear pixels. Let's do clear pixels. That makes a little more sense. Okay, clear pixels. All right, so let's give this program a try. See if this works. Oh, let's see what I did wrong here. Under our setup, we don't want inputs. We want, we don't want outputs. We want input underscore pull up. Okay, and it's complaining about something. Oh, whoops, made that brace backwards. Okay, let's give that a try. Then we can actually check out our colors, see how that looks. Oh, we got more. Oh, need one more end parentheses. We need the digital read parentheses and the if parentheses. Oh, didn't even put a semicolon. Man, all sorts of sloppy here. One of these days we'll get to this. Get to actually programming this. All right. Cool. Oh, okay, it's backwards. So red, blue, green, yellow. Why does those look the same? That's not right. Yeah, why do those look the same? So sections. So it's 0, 1, 2, 3. So yeah, there's 4 colors on here. Okay, yellow looks pretty yellow. Did I? Oh, I see. Okay, so what do you have? Yellow, green, blue, RGB, red. Oh, okay. Yep, got that backwards. 255, 0. Also, the buttons are backwards, where yellow is over here, red's over here. So what I can do is go into my pinputs and just swap all those. So 5, comma 4, comma 3, comma 2. Okay. Let's upload this, see if this works here. All right. Hey, there's yellow, green, blue, red. Cool. All right, they work. Okay, so now we have our Simple Simon play space, and it's all working, right? Okay, so now we need to actually create a pattern for people to guess. Okay, so up here in the code, I'm gonna make a long string, a long array. Call it byte. Uh, yeah, what are we doing here? Byte Simon. There we go. Byte Simon, and we'll make it, I don't know, 60 long, 60 bytes. Okay, if people can guess over 60, then maybe they're writing it down. I don't know, but we'll make 60 the max here. Okay. So we'll also have to make a byte or some sort of integer. I'll make an integer called length. Length? I don't know. So when you need to hit one, you just hit one of them, and then the next time you hit two, and it needs to make two of them go and flash. So we need to call that something. We'll call that game. Okay, kind of an overall. Not a very good variable name for that, but that's all right. Okay, so first of all, under a loop here, get rid of all our tester code. Okay, game plus plus. Okay, actually, no, we'll start game at 1. So we'll say game equals 1. There we go. So first thing it does is it displays everything, right? So I guess under our serial setup, okay, so maybe we'll do it in loop. We have to set it to a random value here, right? Okay, so first thing we're gonna do is, let's see. Yeah, maybe game should be at 0. Going back and forth on this. Sorry, makes sort of a crummy video, but whatever. Okay, so let's see. We have Simon game equals random 4. Okay, there we go. So wherever it's at right now, and then we'll do a game plus plus. All right. So now there's 1 point in the game, right? Or int a equals 0, a is less than game, a plus plus. Okay. Let's see, what else are we doing here? We need something that says whether we're like winning or losing, but we'll worry about that in a second. Okay. So first thing it does is it has to show us like what we're actually doing, right? So we're gonna do a set Simon. Let's see, there's our set Simon. So set Simon and Simon A. All right. We'll do a strip dot show, and then we're gonna do a clear pixels. Oh, we'll do delay here first. We'll have it show up for 400 milliseconds. We can change that later. But we'll try that. So it's going to show it, right? Show all the things, and then it needs to repeat this here. 4 and a equals 0. A is less than game. A plus plus. Still not happy about the name of that variable, but that's okay. Oh, memory. There we go. I like that. We'll call this mem. Mem for memory. So change that to mem. Change that to mem. Change that to mem. Change this to mem. Okay, so first thing it does is it puts a random variable in the Simon array here, right? And then for each one of these, it starts displaying it. So if we had like 30 of them, it would go display it one every 400 milliseconds. And then we need to, after this, I guess we should show a blank thing. Strip dot show. Okay. Now it's all blanked out. Now it's your turn to put it in. Okay. So while yeah, we'll use a while function. While, let's see, we'll have a boolean called guess. Bool guess. Okay. So right now, guess equals 0. Okay? While not guess. So while guess equals 0, while you haven't guessed, we're just going to wait for a button read. For int a equals 0, a is less than 4, a plus plus. Okay? Okay. So if if not digital, right? If we actually push the button down, if not digital, read pinputs a a. No, we're on B here. That's right. That's the a loop up there. So we need to use a different variable. There you go. So if not digital read pinputs B. Let's see. So I guess we should have a game. Okay. So bool guess. Bool win. There we go. Bool win. We'll call that good. So if no, not if digital. Let's see. If a, no, if B, that's right, because we're on B here. If B equals, let's see, equals Simon A. There we go. Because Simon right now, the first one should be, 0, 1, 2, or 3, right? As we're filling it up one by one. So if we get it right, so A is going through all the Simons, right? So this one showed all the Simons, and now we're going through each one of these. Okay, if you guess it right, so if B not equals, we don't want to assign it, we want to test it, equals Simon A, then I guess what are we doing? We'll do set Simon B. Okay, strip dot show delay of 250, delay of 100. There we go. So it's no, we'll show it for 250. Sure, quarter second. Okay, and then no, because people might touch them fast. We'll do delay of 100. Okay, so delay of 100, and then clear pixels. Pixels, clear pixels. All right, there we go. Okay. Oh, we also have to have the button latch so it doesn't just hold, right? That would suck. Bool latch. Okay. So if that goes on, let's see. So what are we doing? If B equals this. Oh, yeah. If you press it and not latch. There we go. Oh, but I use the right and. All right. So if you press that button. Whoops. Oh, wait. We want that one. Did I delete? I did delete that. Okay. There we go. So if you read that, if you press that button and latch isn't set up yet, okay, first thing we do is latch equals 1, right? So whether you get it right or not, it's still latching it down. Okay. So latch equals 1. If you did it, show it. Else, see, game equals 0. Game equals 1? I don't know, that'll be the game over. Okay. Let's see. And then we want to escape all the loops here. So we're at int a is less than memory. So we definitely want to get out of that, right? So a plus, no, I guess a just equals, a equals 60. There we go. Because that's our max right now. So at 60, it'll jump out of these for loops because it's going to repeat these while a is less than memory. Memory is a maximum of 59, right? So if I hit 60, then it's just going to leave it. Okay. Okay. So if you press that, check if you want or not, right? Then if you let it go, if not, no, so if digital read pinputs. No, let's see. So yeah, the current one. Yeah, that's right. Okay, yeah, pinputs B and. There we go. And latch. Latch equals 0. Delay of 10 or so for debounce. Okay. So that's really about it. I mean, we're gonna have to add a ton more stuff, but let's see what goes on right now. Let's see how this works. We have to have some celebration too. Oh, what do we got here? Simon mem equals random 4. So Simon, yeah. We got mem set up. Yep, we got mem set up at 0. Oh, I see what I did. There we go. I used brackets instead of parentheses. Oh, probably want to get a parentheses up there. All sorts of sloppy today. Gonna go through my other code and make sure I got other stuff on there. Yeah, that's looking good. Okay. Game was not declared. Oh, win. That's right. Win. Let's probably do win equals 0. We'll set win to 1. That way, if win equals false, we do something. Not necessary to do that, but it's a little more human that way. As we are humans. All right. So it runs a circle and it does red. I hit red. Yeah. Okay. Oh. Okay. So while guess, that's right, because we're stuck in this loop here, right? So if you hit a button, guess equals 1. Okay. So now you took a guess. And then once you let it go, it goes to the next one. Okay. All right. So red, hit red, red, green, red, green, yellow, red, whoops, green, yellow. Huh. Okay. That's a little weird. So if you get it wrong, A equals 60. Oh, I guess B also has to equal 60. B equals 60. B? That's right. Yeah, yeah. Okay. So win equals 0. I have to do some resetting here. So win equals 0. And then as we leave out of this, So let's make sure we're set up right here. So each of these ends there. Yep, that's right. Okay. So if you get one wrong, it sets everything back to 0, right? So if not when, let's see. So mem equals 0, right? So it's going to start back at 0 here. It's going to set that to a random number, mem plus plus. Okay. And I think that's all we have to reset, huh? Mem back to 0. But if you do guess it right, if when, I don't know, let's do a sparkle. So we'll do, I don't know, a bunch of sparkles for int a equals 0, a is less than 50, a plus plus. Okay, strip dot set pixel color. And we'll do a random one. Random LED count. That's right. In that parentheses, comma. I don't know. Don't want to blind people. 50, comma. Maybe we do want to blind people. We'll do 85, comma 85, comma 85. Okay. So blind them, but not too much. Then we'll do a strip dot show. Then we'll do a delay. Let's see, we're doing this 50 times. So if we do a delay of 20, that should last about a second. Okay. Then we'll do clear pixels. I'm gonna use that subroutine a lot. Get our money's worth out of that subroutine. Okay. Then it's gonna repeat that. So it's gonna sparkle 50 times. And then we'll give it like half a second for people to like, okay, done looking at sparkles. Now look at the next piece. And so if when, yeah, what do we do here? So if we lose, maybe we should have flashed the right one. Okay, so 4 int a equals, we'll flash it 10 times. So a equals 0, a is less than 10, a plus plus. Okay, so what are we doing? Set Simon, right? Let's look at our subroutine. Set Simon. So set Simon A. Okay, strip dot show. And then we'll do a clear pixels. Oh, we'll do a delay first. Delay of 50. So you either get sparkles at 50 or I guess it's only going 10 times. We'll do, let's see, 100. Okay. And instead of set Simon, we'll do clear pixels here. Clear pixels. There we go. So I guess this will take 2 seconds. Yeah, maybe 50 was the right one. 50, 50. Okay, cool. So it takes 100 milliseconds to do each of these. It's 10 times, so it takes a second. So it's going to flash it and set us back at 0. Okay. Let's upload this and see if this can work. Oh, one thing I messed up. So if not when, if when, then yay. If not when, oh, we got something highlighted. Let's see, expected something before something token. Not showing me where. Okay. Oh, right here. Okay. Oh, whoops. Okay, if you're not when, it flashes it, but it's got to reset when, right? So if not when goes back to 1, and then it tells you, what you should have hit by flashing it a few times. Let's give that a try. Let's see what happens. Strip comma show. Nice. Probably couldn't see that on the YouTube video, but with this screen I have, I can actually see that. All right. So it's going to run the circle, and then, so red, hit red. Yay. Red, yellow, yay. Red, yellow, yellow, red, yellow. Oh, okay. Red, yellow, blue. Yay. I need to put a flash in there. Red, yellow, blue, red, red. Oh. Okay, so that's yellow. Yellow, yellow. So I'm going to get it wrong here. Huh. Yeah, it just flashes it around. Let's take a look at if we get it wrong. So if you lose, set Simon A. Oh, no, set Simon. Let's see, what are we doing? Set Simon. How do we work this up here? Mem. Oh, Simon Mem. Simon bracket Mem. There we go. Let's give that a try. Set Simon Mem? Is that where we're at? No, that'll just show us the last one. So that's still wrong. So we have to make an integer called current. Int current. Okay. Because if I do this, right? Wrong one, but it flashes that yellow one. So I hit green. Yay. Green, yellow, green, yellow. Green, yellow, yellow, green, yellow, yellow. Oh, okay. That's really weird. It shouldn't latch like that. Green, yellow, yellow. And hit red. Huh. Yeah, all sorts of weird. Anyways, so on here, see if while you're guessing, so current equals A, and it's gonna flash the current one you are on if you lose. Yeah, we also have to put a clear pixel in there too when it shows us. So it clears the pixels, and then we need to do a strip dot show, and then delay of, I don't know, 100. Okay, now this one's redundant. Hit upload. Gonna get it wrong real fast. Okay, still showing me the right one. Cool. Oh, it's uploading. All right, so runs the thing in a circle. Hit red. Yay. Red, yellow. Red, yellow. Red, yellow, yellow. Red, yellow, yellow. Okay. Red, yellow, blue. Hooray! Red, yellow, blue, red, yellow. Oh, it detected it twice, which we definitely don't want. So I'm going to up that delay here for the debounce to 50. Okay, I'm also going to, after it's done flashing at us, clear pixels and then do a strip dot show right there. Cool. Okay. That way it only lights it up for 100. We'll make it 150. There we go. And we can make this program much better, but much more complicated if we were using Millis to do everything. But we're going to keep this basic. It's already a tough enough game to understand. And we're what, 40 minutes in, 45 minutes into this? So big old program. So red, hit red, yay. Red, yellow, cool. So red, yellow. All right. So red, yellow, yellow, blue. Oh, okay. Regather myself. Let's see if it flashes anything. Oh, okay. That's weird. It flashes, but it doesn't reset the game. Huh. Okay. Let's try that. So I hit blue, yellow. Okay. So yellow, 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 blue, yellow, yellow, blue, blue. So okay, if I hit yellow and then just go blue. Oh, one more yellow. But it should be restarting. So we're missing that. Okay. So if not win, see sets mem back to 0. Yeah, okay. So sets win back to 1. Mem's at 0. So sets that 0 point to a random color, mem plus plus. Now a equals 1. Okay. So yeah, let's discover why it's doing that here. So yeah, flash is the one you should have hit. Okay. Went back to 1. I want to put that at the end anyways, keep it organized. Okay. So yeah, if you guess it wrong, it's at 0. But then why does it go right back? Huh. Let's see. So I can hit red. So red, blue, red, blue. Okay, red, blue, green. Nope, should have hit that one. Waits a little bit and then doesn't restart. Okay. So waits a little bit, right? Yeah, why does it wait a little bit? Is that where it's actually showing what we should have done? Yeah, okay. So Simon Mem, so which is back to 0 equals random 4. Let's uh let's do some serial monitor here. So if win, so if we lose, serial dot print loser. Okay. What else are we doing here? See, we'll print memory. Okay. Go to the next line for this one. And then memory. And then print out mem. Go to the next line. Okay. If win, see. Hooray. No participation trophies in Simple Simon, it looks like. You either win or you don't. Cool. And eventually you're down here. Okay. So sparkles. Waits half a second. I want to get rid of that last sparkle, that lingering sparkle. That's kind of annoying me. There we go. Okay. So what else are we looking at? So as soon as we start here, we'll print. We're going to have a cheat sheet here. Kind of. Print, yeah, Simon Mem. So whatever one we're at there. Cool. Okay. Okay. Now let's look for some bugs in the serial monitor. Okay, because it works, but doesn't work quite right. Okay, does our ring? So it's red, red, yay. Then it's red, yellow, red, yellow, hooray. Red. Oh, I didn't even see it. Oh, I guess it shows in the serial monitor here. So red, yellow, yellow. All right. So red, yellow, yellow, blue. Okay. Red, yellow, yellow, blue, red. Cool. Now let's get it wrong. Red, yellow, yellow, green. Oh, should have been blue. And then it starts with yellow. Okay. Okay, so it worked. Oh, there it is. Okay. If you lose the game, like if it should have been blue, but the first one starts blue, you wouldn't know it because it lit up. There it is. So the game's all good here. Okay. But it goes so fast to start the next game. Okay, so if you lose, flash it a couple times. Okay, there we go. And then we have to do a delay of 1,000. Okay, let's give that a try. There we go. Okay. So I didn't even see it, but I have serial monitor up here. So red, hooray. Red, yellow, red, yellow. It's going to be very familiar, by the way, because the random generator isn't the greatest. And we'll look up how to make a better random generator in just a second. Cool. Okay, so now if I hit red, yellow, green, oh, should have been yellow. Waits a second, and then it starts. Cool, so now I know to hit yellow. Yellow, yellow. Boy, it likes to repeat yellows a lot. Yellow, yellow, red. Yellow, yellow, red. Green? No, it should have been blue. Okay, and then it starts over. Cool. Now we've got a perfectly stable program, okay, of Simple Simon. So red, blue, green, red, blue, green. Cool. Red, blue, green, green. All right. Okay. So I've got this Simple Simon set up. In the next video, I'm going to show you how to make it nice and finished. Okay. So we've got the basic program working. Now we're going to make the randoms better, make the visualization better, all sorts of stuff. Thanks for putting through this 50 minutes or so of video, and I'll see you next video.